Let us begin Chapter 7, Section 1. After you have read the objectives, you can go ahead and do the examples. Let's look at example number 1. An experiment consists of drawing a single card from a standard deck of 52 cards. What is the probability of drawing a black jack? So the probability of drawing a black jack, and here you have two black jacks. You have the black spade and the black clubs. So 2 out of 52, which is 1 out of 26. Number 2, an experiment consists of drawing a single card from a standard 52 card deck. What is the probability of drawing an ace of spades? So the probability of drawing an ace of spades, and here you only have one ace of spades. So 1 out of 52 chances of drawing that ace of spade. Number 3, an experiment consists of drawing a single card from a standard 52 card deck. What is the probability of drawing an 8? So the probability of drawing an 8, here you have 4 8s in a standard deck. So 4 out of 52, which is 1 out of 13. Number 4, an experiment consists of drawing a single card from a standard 52 card deck. What is the probability of drawing a 6 of hearts or a 6 of spades? So the probability of drawing a 6 of hearts or a 6 of spades. In here you have 1 6 of hearts, 1 out of 52, and 1 6 of spades. Therefore, 2 out of 52 is equal to 1 out of 26 chances of getting those 2 cards. Number 5, an experiment consists of drawing a single card from a 52 card deck. What is the probability that the card is not a black 6? So the probability of not being a black 6. Again, remember you have 2 black 6s, so 52 minus 2 gives you 50. So you have 50 that are not black 6s. So 50 out of 52 is equal to 25 out of 26. Moving on to number 6. An experiment consists of rolling 2 fair dice and adding the dots on 2 sides. Assuming each simple event is equally likely, find the probability that the sum of the dots is an 8. So to find the probability of the sum of the dots is 8, so I can give you the sample space that is equal to 8. If you roll a 2 and a 6, that's equal to 8. 3 and a 5 is equal to 8. 4 and a 4, 5 and a 3, and 6 and a 2. Those are all the possibilities of rolling a sum of 8. So you have 5 out of a total of 36 outcomes. And that's your answer, 5 out of 36. Number 7, an experiment consists of rolling 2 fair dice and adding the dots on the 2 sides facing up. Assuming each simple event is equally likely, find the probability that the sum of the dots is not 7. So the probability that the sum of the dots is not 7. So here let's see how many of the dots are equal to 7. So let's do the opposite. 1 and 6 is 7. You have 2 and 5 is 7. 3 and 4, 4 and 3, 5 and 2, and 6 and 1. So you have 1, 2, 3, 4, 5, 6. That's equal to 7. So 36 minus 6 gives you 30 outcomes. So 30 out of 36 is not equal to 7, which is equal to 5 over 6. Number 8, an experiment consists of rolling 2 fair dice and adding the dots on the 2 sides facing up. Assuming each simple event is equally likely, Find the probability that the sum of the dots is divisible by 4. So find the probability divisible by 4. So we're looking at 4, 8, or 12. These are all numbers that are divisible by 4. And here you have 9 that have a sum of either 4, 8, or 12. So 9 out of 36 is equal to 1 out of 4. Number 9, an experiment consists of 2 fair dice. Again, adding up the dots on the 2 sides. Assuming each event is simple, find the probability that the sum of the dots is odd. So finding that the sum of the dots is odd, and looking at your sample space, you have 18 out of 36. That's odd, which is 1/2 is odd. And number 10, again, find the probability the sum of the dots is greater than 1 and less than 5. So again, looking at your sample space, all of the outcomes are greater than 1 and less than 13. So it's total 36 out of 36, which is equal to 1. And this completes section 1 of chapter 7.